Now in this video we'll see how PIM sparse mode is going to operate in different steps. Now before we go ahead, let's quickly revise the PIM sparse mode. We have two different modes, a sparse mode and the dense mode. Now the sparse mode is much more scalable when compared with the dense mode, because in case of dense mode, the one which we discussed in the previous sections, it's going to work based on flood and prune behavior. So initially the traffic is flooded out of all the interfaces, and then if you have a receiver who do not want to receive the multicast traffic, he's going to send out a prune messages. Now that's something, the major drawback with the dense mode is it's really not scalable. But whereas in case of sparse mode, it is not going to do flooding. Instead, it is going to send the multicast traffic only when it is requested for. So that's the major difference between the sparse mode and the dense mode. So it uses explicit join. Explicit join is just like, you need to tell that I want to receive the multicast traffic, then only the multicast traffic will be sent, or else it will not send unless you ask for it. It uses both shade tree as well as source tree. We'll see how it's going to use shade tree and source tree more in detail. And probably the sparse mode is much more scalable solution when compared with the dense mode. Now the complete dense mode, sparse mode operation is going to happen in 6 different steps. Now we'll try to get into more in details on what are the different steps it's going to do. Now the first step is it discovers the PIM neighbors. Now the router, let's say we have a router A and router C, and these two are configured with a command called under the interface. We need to say IP PIM sparse mode, just like we did the configuration of dense mode. Now once we enable this command on the interface, it is going to discover the neighbors based on some multicast address 224.0.0.13, same like dense mode. And there is a periodical hello messages sent between these two neighbors for every 30 seconds, and the default date time is 90 seconds. Now the first thing, they need to discover the neighbors. So like that, the same thing happens between every two routers. They need to identify the PIM neighbors. Now once they discover the PIM neighbors, once we enable multicasting and the PIM on all the routers, now the next step is they need to decide the RP, or every router should learn about the rendezvous point. Now the RP is the root of the tree. We can say it is the root of the tree, or a central point, or the router which is going to provide the information about the source who is sending the multicast traffic and to the destination. So the information from source to destination is something provided by RP. We can say RP is a reference point for the complete route of the shade tree we can send. Now in order to send and receive the traffic, the source who is sending the multicast traffic should know about RP, and the receiver who wants to receive the multicast traffic, they should know who is RP, so that they can register themselves with RP, and the RP will provide the information multicast traffic from source to receiver. Now this RP can be manually configured by using some commands. We can either specifically go and manually configure on each and every router that who is RP, or we can advertise the RP information to all the routers by using some dynamic RP configurations. So we'll be getting into that more in detail with specific configurations in the later on sessions. Now once the routers learns about the RP, now the next step is the source. Now the source who is sending the multicast traffic, they need to register themselves with RP. So that's the next step. So RP listen to the source by using some PIM register messages. Now in this third step, now the source must register themselves with RP. Now the source here is going to send something called PIM register messages, and they should register with RP by sending some unicast PIM register RP messages. Now if the RP receives or accepts that particular message, it acknowledges back with a register stop message. Now register stop message is just like a confirmation that okay, you are an RP, I'm going to agree, you are a source, and the source is going to send that I am the source for this so and so multicast group address, and this is my IP address 10.1.1.1, and the RP is going to maintain some S comma G entries in that, saying that if I have any receiver who wants to receive the multicast traffic for this group address, I'm going to send it back to 10.0.0, 10.1.1.1, and it's going to write that in the routing table. Now at this point, only the source router and the RP knows about this S comma G entry. Now the RP knows the entry for source and the group, and the particular source knows this entry. Whereas all the remaining routers, they don't know any information about the source and the group. But whereas in case of dense mode, every router simply gets the information of S comma G entries. But here it's not like that. Now the source has to register themselves with RP, and they have to tell that I'm the source for this particular multicast group, and this is my IP address. Now again, there is something called RPF check happens here as well. Now the RPF check is done based on the register message it receives from the source, and if the RP do not have a route back to the source on the receiving interface, it is not going to accept the registration messages or PIM register messages. That's something like, the source is going to send back a PIM register message. Now when it is sending a PIM register message, it's going to verify the reverse path forwarding check back to the source, and it will ensure that on whatever the interface it is receiving, it's going to match. It should match that RPF check, and if it matches, it's going to accept the PIM register messages, and it's going to acknowledge back with the register stop messages. If not, it's not going to accept that. So again, the RPF check is also done here based on the same conditions again. Now the fourth step, RP should also know about the destination as well. Like here, just now we discussed that RP is the root of the tree. Now the source has to register with some PIM register messages. Now similar way, if we have any receivers, like let's say I have a receiver here who wants to receive the multicast traffic for this particular group, and this is the source address for this particular group. Now the RP knows that information. Now what the receiver will do is, receiver is going to request or send an ICMP join message to the nearest hop router, that is the first hop router. And what this particular router is going to do is, it's going to send back a join message to the RP saying that, hello RP, I have a receiver who wants to receive the multicast traffic for so and so group 224.5.5.5. Do you have any information how to reach that particular source? Now the receiver has to register themselves by using some PIM join messages. Now here RP is the root of the tree, and it should know about both the source and the receivers, and it's going to learn about the source by using some PIM register messages in the third step, and it's going to learn about the receivers based on the PIM join messages. Now all the routers in the reverse path here, now once the RP receives a join message from the particular router, PIM join messages, now all the routers in the reverse path towards the RP are going to install something called asterisk star comma G entries, and forward the join messages hop by hop towards the RP. Now which means it goes hop by hop. Let's say this router is going to send, I have a receiver here, it's going to send an entry, and they are going to join star comma G entries and then star comma G entries towards the RP here. Now at this point, all the downstream routers towards the receiver from the RP, they will have S comma G entries. Now from the RP here towards the downstream router, they all have a star comma G entries, and from the RP towards the source, it will have something called S comma G entries. Now that's the fourth step. Now at this point of time, now you have from sender will have S comma G entry. That's the first point, and the RP will have an S comma G entries, and all the other remaining routers, all the remaining routers, they have just an entry of star comma G. So they just have that information that if they want to go to any multicast group address, they will send it to RP. They just have upstream towards the RP. So RP knows exactly where is the source for that multicast group. Now the next step is, it's going to build a shade tree from sender to receiver through RP. Now once the RP knows about the sender, now RP knows about the sender based on the PIM register messages. Now the RP also knows about the receiver based on the PIM join messages. Now the RP is going to send PIM join message up to the source. Now it's going to receive the PIM join messages, and then RP is going to send that I want to join to this particular group. So that's what it's going to send. Now all the routers in the reverse path, again from the RP to the source, install asterisk comma G entries here again with the output interface facing towards the RP again. And the multicast traffic begins to flow via RP to the receiver based on the star comma G entries. Now once it's going to build a shade tree, now they will from the source towards the RP you have a star comma G entries. So the multicast traffic goes through RP, and from the RP it will flow back to the receiver with the star comma G entries. Now this is the next step. It's going to build a shade tree from sender to receiver via RP. Now after that, finally the last step, it is joining the shortest path. Now once the receiver here, now there is a receiver here and you have a sender here, multicast traffic. Now when a receiver sees the traffic, star comma G here, that is the group address from the actual source. Now actual source is here 10.1.1.1. From the actual source, they will initiate a PIM join message towards the source. Now it is going to send a PIM join message towards the source. It's going to send the join message directly to the source, ignoring the RP here. And it's going to build the shortest path tree based on S comma G entries, again from source to receiver. Now the routers will know about the actual source. Initially they are going via RP based on this star comma G entries. Now they are going to build a shortest path from source to receiver directly, ignoring the RP here. Now this new tree follows the optimal path from the source to destination, and it removes the RP for forwarding all the multicast traffic. Now it's going to remove the RP, the need for the RP, because the source and the receiver, they know each other directly based on the shortest path. Now this process of switching from asterisk comma G, the star comma G, to S comma G entries, we call it as a multicast as shortest path tree switchover. And once it shifts to the shortest path, now the receiver router is going to send out a prune message to the RP saying that, hello RP, now I got a best path to reach the particular source. It's going to inform to the RP saying that it tells the RP that to remove this interface from the list, so that it doesn't need any multicast traffic via RP, because it has found the shortest path here. So this process of switchover from actual source tree to the shade tree here. So initially, if you're running the sparse mode, it's going to run a source tree where your traffic will go via RP, but the receiver is going to figure out the shortest path from the source to receiver, and based on that, it's going to build the shade tree again.